Tak a další přednáška bude v angličtině. Přijde Nachmany, který k nám přijel z Izraele. Ran už několik let programuje pro Android a dělá konzultanta a je uznávaným Google Developer for Android od Google. Right, it's yours.
Hi. Thank you. As you said, my name is Ran. I'm from Israel, so we're going to do that in English because I don't think my Czech or your Hebrew is good enough. Okay, we're going to talk about how to make your apps butter, and it's not a mistake. Butter means product butter. Let's try to make your apps run buttery smooth. Before we dive in, a few words about myself. Actually, I'm an electric engineer, got a BSc in EE. I spent about 10 years developing chipsets for the wireless industry, WiMAX, Wi-Fi, LTE, the stuff that we all have in our mobile phones. About 4 years ago, I left the hardware and moved to software, and I dumped into Android. Today, I'm a Google developer expert in Android. There's about like 15 people like me around the world, and I'm here on behalf of Google. In Israel, I have my own company, and I help a lot of companies and startups go into the mobile arena, and most important, I can break. Okay. All right. So today's session is not going to be a traditional, some slides, some talks, some words. We're going to do a lot of live things, live codes, and let's hope everything will work as we planned it to be. So for today, I created this application, which basically it's a list view that loads images of my kids. And you can scroll and images are being loaded, and there is like a text view and how many people plus one images. And the issue is that when I scroll, it's hard to show it and display it through the camera here. I have a feeling that the scrolling is not as smooth as it should be. I mean, it's a Nexus 4 device, it's the top-notch device, and still it's not that smooth as it should be. And what we're going to do, we're going to try and analyze and hunt down and fix all the issues that we have here. So our goal is 60 frames per second. We want to render and display on the screen 60 frames per second. That's the key to smooth user experience. That means that we have 16 milliseconds per frame to draw each frame. Okay? This is the rate that we need to work with. We need to start thinking like embedded in real-time programmers for a second. Our drawing operation needs to be less than 60 milliseconds. So if this is my my VSync signal, okay, this is where we draw the screen. The screen displays a frame here. We draw on a shadow buffer the next frame, and then on the next VSync signal here, we're going to swap buffers, and the new frame will be displayed. We're going to start drawing on the shadow buffer the next frame, and so forth and so forth. Okay, you need to think that in these drawing cubes here, there is your code running, and also Google's code, the Android framework codes running. Okay, it's a mix of both. All right, so we're going to try and see why and where we're missing frames. There are a lot of issues and common mistakes that will cause you to lose frames. I'm going to start with the common one. This is where your drawing operation takes too long. If it takes me more than 16 milliseconds to prepare the next frame, over here, I'm losing a frame. This means that here the screen will not be refreshed because we don't have a shadow buffer ready. Okay, so the old frame will be displayed for another extra 16 milliseconds. Users notice it. Okay, they can't pinpoint. They don't know exactly that, hey, the same frame has been drawn twice, but they have the feeling that things are stuck. It's not that smooth, okay? Being an Android guy, the word that I had, people tell me it's not as smooth as in iOS, okay? So first thing we need to know is, do we really have this problem, right? How do I measure how long it takes me to draw my frames? And starting with Android 4.1, Android has a utility that helps us measure this exactly meter. So in order to activate it, you need to go to settings. I don't know if you guys are familiar with all the developer options. Under developer options, you can have right here profile GPU rendering. You just make sure you check that, okay? And then we can go to some code. Basically what it does, once that flag is checked, Android will keep the timing that it took to display the last 128 frames. That's about 2 seconds, okay? So we can just scroll, and in order to display those numbers, this buffer, you just go with adb shell dumpsys gfix info and your package name. So I'm gonna run a little scrolling here, and we're gonna display, and it doesn't work. Just yeah, right. You need to kill the process and start it again. There we go. Okay, so we've got a lot of numbers on the screen, okay, and in 3 columns. The first column is draw. Draw is the time in milliseconds that it took your application, your Java code, to draw its views. This is the time that your application spends in all the onDraw functions, okay? Process is the time that it took the Android compositor and choreographer code to take all your views, translate it to OpenGL commands, and write everything into the shadow buffer. And execute, it's the time that it took the Android OS to swap buffers. So out of these 3 columns, draw is your code, process and execute are Google's code. Okay, and it's important to understand that these 3 phases, these 3 stages, are happening one after the other. They're not in parallel. First, we need to finish the drawing, then process, and then execute per frame, which means that the time that it took me to draw a specific frame is the time it took me to draw it, process it, and to execute it. Okay, and just by looking here, I can see that sometimes I have a very long process time. Okay, we just lost a frame here. Actually, we lost 3 frames here. Okay, and here we lost 2 frames. It took us 36 milliseconds just to do the process. Okay, since it's sometimes a little bit hard, here we can see some more frames that we lost. Since sometimes it's really it could be tricky to run over the numbers just with your eyes. I like to what I like to do usually is just a second. All right. No internet. Okay, what I do usually, I go to, I take everything into just a Google Sheet, okay, and then I do a chart, a bar chart, right, here we get it. That's stacked bar chart, and the blue is the draw, red is the process, and orange is the execute time. And every time that the sum of these 3 exceeds or tops 16 milliseconds, I know that I'm losing frame. And obviously here we can see that we lost frames, and we need to fix that. But I just told you guys that process is not your code, right? Your code is the draw. So what can we do? And it's true. The process is Android's codes, and they're working to optimize it and make it more efficient. But we need to understand and remember that the input to the process is what came out from your own draw. So the input to the process phase is your application, what your application produced. And maybe there are some things that we can do to make the process life easier. So one of the common things that causes a long process is too many layouts, and I'm not going to talk about that, but I'm going to talk about overdraw, which is very common. Overdraw is something that is very simple to understand. It means that we're painting the same pixel more than once in the same frame. There's a pixel, we're painting it in one color and then different color and then different color until the last color is being displayed. Okay, starting with the 4.1 again, it's very easy to detect overdraw and to fix, and I'll show you. First of all, here's an application that does a lot of overdraw. Okay, as you can see, with your naked eye, you don't really see it. Okay, everything looks just like a white screen. But in order to visualize overdraw, you can again go to settings, developer options, all the way down to the bottom. Show GPU overdraw. Again, you need to kill the process, and bam. Suddenly the white screen is not that wide. What happens here is that Android paints all the pixels that we paint more than once. So up there at the top, it's hard to see, it's painted in blue. That means that we've painted these pixels twice. Okay, which means we're having overdraw of 1. Okay, green means that we've painted these pixels 3 times, overdraw of 2. Light red, we painted 4 times, which means overdraw of 3. And dark red or more is we've painted the same pixel 5 times, we're having overdraw of at least 4. Basically, if we'll take a look at the layout of this screen, it's a linear layout. Inside it, 2 linear layouts, half at the top, half at the bottom. And the bottom one, again, 2 linear layouts. Each one is drawing white background on the screen. Okay, so if we'll go to the code in a second, we'll be able to see it. But if I'm gonna take a look at my application, and let's see if I'm suffering from overdraw, and obviously we have a lot of reds here. Okay, now important to understand, our mobile device has a GPU inside it. Okay, the GPU has enough horsepower to process between 2 or 3 times the number of pixels on the screen. That means that the GPU can draw each pixel on the screen twice, sometimes 3 times per frame, not more. Okay, so our goal is to be without reds. All right, blue is good, green is okay, red is dead. Okay, that's easy easy to remember. Okay, so let's hope that our life are good, and we have unicorns all over the place. Let's take a look at my my XML. This is the XML of every row. We have a linear layout with a 9-patch background, image view for the background, image view for the photo itself, and then image view for the text view for the +1s, and image view for the icon. I don't see a lot of overdrawing here. I don't see views on top of views on top of views. It's hard and can be sometimes very tricky to understand where the overdraw is coming from. We know for sure that we're overdrawing here, right? But we don't know why and where. So let's introduce another method that I'm using, and that's the hierarchy viewer. Hierarchy viewer basically lets you lays out all your layout. Note, it doesn't work on real devices. Okay, in order to run the hierarchy viewer, you need to either connect to an emulator or to an engineering device running insecure Android ROM. So we have here all of our views. We can see here on the side the layouts. I can click on each view and I see what it's being painted, and for each one we'll get a screenshot, and we can learn a lot from this tool. But what I would like to show to you is a nice little trick that I do to find overdraws, and I use this button, which basically says capture the window layers as a Photoshop document. So you just grab it. Let's save it. All right, and it takes some time, so we can just skip and open the one that I took earlier, and we can open it with GIMP or Photoshop or whatever. And we'll have basically the screen of the device with all the layouts. Okay, here on the side we have the layouts, and if you can see, the layout names are exactly their IDs, as I gave the IDs in my XML. And what I like to do is just clean everything. Here we have a clean screen, and we can turn layout by layout and layer by layer and see what is being painted. So first, the entire screen is being painted in white. And then here is the action bar. Here's another layout in the action bar that doesn't paint anything. App doesn't paint anything. Home paints my logo. Okay, we've painted this pixel already 3 times. All right. The title, subtitles, and so forth and so forth. This is all of this. This is the action bar, and here we are in the list. The list has a background, a gray background. So these pixels, already I'm painting the entire screen twice. Okay, now let's take a look at a single list item. Here's a linear layout, painting everything in white. Okay, and then there's my background. On top of it, a photo. Okay, there's another layout. Here's the +1s, and here is the icon. I can go on and turn on more layouts, but it's going to be the same. The next row, it's background, photo, and so forth and so forth. So obviously you can actually see here that we're painting a lot of times the same pixel over and over again. Okay, so let's start and fix it. First thing I want to understand is I want to avoid this whole white. I don't have any white in my background, right? And actually I can go here to my code and look for white. I'm not going to find it. I've never set any background white. I've never said, I don't have it in my color list. Here's my activity main. So that's the menu. Here's my activity main. It doesn't have any backgrounds. The dark background is the gray background that I'm displaying for the list view. Okay, so where does this whole white frame came from? Any ideas? Almost application theme, exactly. Before we even paint our XMLs and our issues and our layouts, Android has the theme, right? So if the theme has a background, it will be displayed, it will be drawn. Okay, so a nice easy trick to do is simply go to your main activity, to on create, and let's set our theme background to null. Okay, just by doing this, I'm reducing one overdraw. So let's run it. And we'll be able to see here that things will look a little bit better. Okay, not perfect, but we're making some progress here. Okay, suddenly what was the areas there was green over here is now blue, meaning that I'm painting it only twice. And the dark red is light red. Okay, we made some progress with one line of code, setting the theme, the background theme, to null. Okay, that's good. We are optimistic right now, so we've solved this one. Okay, let's try and improve our list item. First, we have all this white, right? And on top of it, we're painting the background. Looks like waste of pixels to me. Okay, so where is this white coming from? This white is basically my background of my list item. Okay, this is a 9 patch. We can take a look at this 9 patch right here. Okay, we can see that it has 1 pixel for the content and 1 pixel to stretch. And basically what Android does, just stretches the entire 9 patch. But I'm not interested in the entire 9 patch. I don't want to paint the whole area. I would like to paint only the white on the sides, right? So I can improve my 9 patch from this to this, which looks the same, right? But if we really zoom in, we can see that I've just made a single pixel transparent here. And Android will stretch that transparent pixel because here are my 9 patch anchors. So once it stretches the transparent pixel, it will not paint those transparent pixels and will be good. Okay, so make holes in your 9 patch. Let's change from this to this and take a look at about the color. Remember the color of the screens of the images right now, and let's run it again, and we'll be in better position. Okay, we're green, no more light red, but we can still do better. We've solved the issue of this white, the white on top of the background on top of the 9 patch, the white. But once we load the picture, we're painting the background, and then we're painting the picture. Doesn't make any sense. Now, I do need 2 image views here because I want to present a placeholder and then to fade in my real image once it's been downloaded. Okay, but once I finished my animation, I can drop the background. Right? I don't need it anymore. So we can go to our code, and over here we have this line basically animates my image view after we've done set image drawable. Animates it from 0 to 1 with the alpha, and we can just set listener new animator listener, and when the animation ended, sorry, everything explodes, but but we set the background to invisible. Now if you'll take a look, you'll see that during the fade in, the image is we have an overdraw, and then it reduces. So we touch a green and we go back to blue. Okay, we're almost there. There are still some places that we can optimize here, and I want to talk about that area, the text and the icon right next to it. As we can see, there is overdraw there. Let's take a look in our GIMP. Where is it coming from? It's in our layout because the image is not at the same size. But in my application, and a lot of applications, especially those with list views like Twitter clients, that you have like the icon or the avatar of a person or whatever. The image views are in fixed size. Okay, it doesn't matter what is the size of the image here. All images are, my image views are they all have a fixed size, and they're just doing crop inside. So I don't really need the request layout. Okay. Now this bug was solved in the 4.2, but as we know, most of the devices out there are not running 4.2. So what I use, I have my own image view class, which is called better image view, that where I've added that function called set image drawable no request layout, okay, which basically just puts a flag into a member and calls the super. All right, and I've overridden the request layout, and I'm checking this flag. Okay, if this flag is false, we're doing request layout. If it's true, we're not doing request layout. Now it is my responsibility, whenever I'm using an image view with a fixed size and I'm doing set image drawable, I can, instead of calling set image drawable, I can call set image drawable no request layout, and I've just saved a whole layout sweep, which takes a lot of time. Be warned, it's your responsibility as developers. Okay, if I'm gonna call this function set image drawable no request layout for an image view that doesn't have a fixed width and fixed height, for example, it's wrap content or match parent, things like that, it's not gonna work well. Very bad things will happen on your screen. Okay, things will just fly around. It's gonna be messy. All right, so this is image view optimization. I encourage you to take this code and start using it. All right, let's go back to theory. This is our timeline. This is the timeline. This is our vsync every 16 milliseconds. This is a drawing mechanism. We've reduced it. It doesn't take more than 60 milliseconds now. But what happens if my drawing is very optimized and it doesn't take 60 milliseconds, but it doesn't start in time? It doesn't start right here where the vsync signal started. Something was delaying it, and although the drawing mechanism only took, I don't know, 6, 7, 8 milliseconds, it didn't finish in time. Okay, GFX info doesn't tell me that. It has nothing to do with timing. Okay, so let's try to figure out if we have this problem and how we fix it. So in order to find it, anybody has an idea what tool I'm going to use? Has anybody here heard about systrace? Okay, we're going to focus a little bit about it. Okay, systrace again it's a Linux systrace that was introduced in Jelly Bean in 4.1. In order to activate it, you need to go to settings, developer options. We're going to remove the GPU overdraw. We don't need it anymore. This one we need. We don't need the profile, and we can go with enable traces. As you can see, there are a lot of things that you can trace. I've picked up graphics and views because this is what I want to trace. And I hit OK. And as always, you kill the process and you run it again. And now we can go, it's a Python script that you can either run from a command line, or it's a new addition from the DDMS. I'm going to pick my device, and here this icon basically captures system-wide trace using systrace. So I've got a CPU scheduler marked because I want to know, since you're not familiar with the systrace, I want to show you how much detail you can get from it. And the output is basically an HTML file that you can put here. I can select how much time and buffer. You can leave the default is 5 seconds. All right, so I'm going to go with OK, and I'm going to just scroll while it's capturing. Okay, and it's finished. Okay, so we can close the GIMP. We don't need it anymore. And let's open our trace file. Amazing. This is our trace file, which basically when you at first glance you don't understand anything from it. Okay, so first thing first, how to navigate in this bunch of lines laying on the screen. Who here has played Unreal Tournament, Duke, Quake, any other first point FPS game? Oh, okay, so now we see some hands. All right, remember how you walk? W forward, S backwards, A and D, right? Okay, this is how you navigate here. W you zoom in, S you zoom out, A and D you move around. Personally, I think you need to be able to shoot something here. Okay. On the left side, we see a descriptor for each line. This is what happens in CPU 0. This is what happens in CPU 1, each core. And these are all the binders. We're not going to talk about them, so I can just remove them. Okay. Here's the vsync signal, surface flinger. That's the code that swaps between frames. And here is my package. Okay, this is what we've done. So let's just pick this area. We're gonna zoom in. Okay, you can see that when I click on a bar, I get details down here about it. Okay. Oh, sorry. I've done a refresh. Let's kill this again. Okay. So let's take a look at my code. Perform traversals, that's the entire drawing operation. Okay, that's the sum of what we've just measured with GFX info. We can see here that this frame it took 14.467 milliseconds to draw. Here's the how much time was spent in drawing and how much time Android spends in draw list and so on and so forth. Now, I'm trying to look for a good example of losing a frame, not because it took so long. Here it is. Okay. Here's the vsync signal. Okay. This is the vsync. This is vsync 1, 0, 1, 0. Every green square is 16 milliseconds, and then every white square is another 16 milliseconds. Okay, so this is one frame, this is a second frame, this is another frame, this is another frame. Let's take a look at what happens here. Here's the performed traversals. It took only 9.6 milliseconds. It was fast enough, but it didn't occur in time. Okay, there was like, I don't know, 30 milliseconds here that my code wasn't running. Okay, we've just lost 2 frames. Okay, probably happens here in more places. Here again, it took 8 milliseconds to do the drawing, but it wasn't ready in time. We finished the drawing after the vsync has switched. Okay, we're too long. Why? Because we didn't start in time. Okay, usually you can see that the performed traversal starts pretty close to the start of the vsync. Here again, we didn't start in time. We lost a frame because something was busy. Okay, here we can see that again our drawing didn't start in time. We were busy doing deliver input event for 3.8 milliseconds. This is our code doing something. Okay, and so forth and so forth. So obviously we have issues here, timing issues, where my drawing code is not being called in time. Something is keeping the system busy, and we've seen at one case that it was a deliver input. That's my code handling on touch event. We'll figure out what happens there. And in some cases, it wasn't my code. I don't know what happened there. I don't know why here, okay, my code wasn't running. Okay, and so let's try to do some profiling and understand. The first thing that I'm going to do, actually, I'm going to take a close look at my log cut. So here's the log, and I'm scrolling. As I'm scroll, I can see these lines of code, of logs, sorry. Basically, what do they say? Garbage collection, GC. Okay, GC stands for garbage collections, and pausing the everything for 19 milliseconds, 25 milliseconds. Maybe I'm not doing something right because I'm causing a lot of garbage collection. I need to be a little bit more efficient with my memory handling. Okay, but where is it? Let's try to find out. The next thing that I'm going to do, I'm going to use, let's debug our code and go to the allocation tracker. You can do start tracking, run, and probably some GCs, and get allocations, and stop tracking. And we can see that there are a lot of allocations here for buffers. Okay, this is a buffer which is about 1 meg. And for every allocation, I can see where it came from. I can see here the entire stack trace that caused it. So I see a lot of bytes here, array of bytes. And when I look, I can see the entire stack trace, which leads to list view, get view. And here is my line of code that basically says byte buff equals new byte 1 meg. I'm not doing anything with this byte. It was just for the purpose of this demonstration. So I can understand that this object is being allocated and deallocated a lot. Okay, get view is a function that's being called over and over again. So we're doing a lot of allocations for nothing, right? So obviously, in this case, I'll just kill this line. Okay, for the purpose of the demo. But your life won't be always that easy finding memory leaks or just unused allocation. Okay, I'm almost done. Or finding unnecessary allocations. So you need to think about your allocation and watch for the garbage collection. Actually, we're very good with the timing. Optimizing my code. Use systrace. This is a recap. We're going to use systrace to see if we have timing issues, okay, and if we're doing things not very efficient. Traceview for method profiling. How many here who has used Traceview in the past? 1, 2, 3, 4. Okay, Traceview basically allows me in the DMS, I can do start method profiling and stop method profiling, and I will get a view which is like this, telling me how much time I've spent in every method. There are 2 times here, inclusive and exclusive. Inclusive means the time that I spend in my method and all its child methods, okay? And the exclusive is just my method only, okay? So using Traceview, you can understand if you have methods that are not efficient, they're doing a lot of loops or I don't know what, you'll be able to see it here, okay? So use Traceview for method profiling. Look for garbage collection in your log cut, okay? Every time there's a garbage collection, it means that the entire system is working too hard. Allocation Tracker can help you find out where you're doing unnecessary allocations and where you can improve. And of course, there is Eclipse Mat, memory analyzing tool, that you just dump a age profile from the device. You throw it into Mat, and it will do all the analysis for you and will tell you where you have unused memory. To sum things up, the entire talk, what you need to take from here is measure, optimize, and measure again. Okay, that's about it. So we've got like 3.5 minutes for questions. Thank you.
Thank you, Ran. And now it's time for your questions.
Either they know everything or they didn't understand anything. So it's one of the two. You open the hierarchy view perspective. You can do it either from Eclipse or from the monitor, okay? And once you did open, okay, this one, okay? And when you're here, you click on refresh. It will find out the device. Again, it will work only with the emulator. You can see it doesn't see the device which is connected. And then you hit this button, it will give you the entire view. This one up here. To Photoshop.
Okay, another question? Může se ptát i v češtině, zkusíme to přeložit.
No, it is for every device. Well, the difference will be basically between devices will be in the process time. Depends on their GPU. Okay, but again, as a rule of thumb, all GPUs of all devices are capable of doing at least 2.5 times the number of the pixels on the screen. Okay, so even if you have like a Galaxy S1, which is old, it didn't have a lot of pixel on it comparing to an Nexus 4. Okay, so although the GPU is slower, the amount of overdraw that you're allowed to do in S4 and Nexus 4, S1, sorry, and Nexus 4, it's the same. So it doesn't really change. Okay, although again, all the tools are available starting with Android 4.1, but the results affects all devices. They just in 4.1 we just got these tools as developers to work with and to analyze and to visualize overdraw. Overdraw was a problem that's been existing starting with I don't know 1.6. It's not a huge problem. You can go with some light red. If you'll go and start doing a show GPU overdraw for Google's application, you will see some reds in there. They're improving it. But I mean, the old Gmail was all red. That's why it didn't scroll good. So you need, I mean, nothing is written in stone, okay? So you need to avoid those. If you don't have any way to overcome it, then what can you do? But usually you'll be able to go along with one overdraw, two overdraws to draw a pixel. Okay. For example, in my application here, I do have some extra overdraw when I'm doing the fade in, fade out. Okay, and then I just drop whatever is behind me.
Next question.
For specific time range, there is no easy way to do it now, today. There will be in the next Android that will come. You'll be able to do in your method start and stop, and then you'll be able to measure a specific time. Okay, animations are hard, obviously. And here I'm doing animation, an alpha animation. If you'll take a look at the code that I'm doing the alpha animation, I went over it very quickly. I was doing it with the property animation here. So basically Android today has two animation mechanisms. One which is up to 3.0, up to Honeycomb, and one from Honeycomb and up. And starting with Honeycomb, also they also introduced the hardware acceleration for animation. So if you're running on top you know, for example, honeycomb and above, you can go with the add. Sorry. Great. Okay. This never happened. There we go. Eclipse never stacks, right? Okay. Yeah. Anyway, you can use a set layer type hardware. It will die in a second. Set layer type hardware, or as I did here, go with layer. Will tell the animation to render everything in hardware. Again, this is for devices running 3.0 and above. Before that, below that, you have nothing to do to optimize it. The karma here just tells me to go, right? you guys will do anything to kick me out of the room. Okay, so this is what you do. Just try to go with hardware layer acceleration. Last one? No, last one. Okay. How the what? Web view, terrible. You don't want web view. Okay, I mean real content you don't want to do that in WebView. It's terrible. Even if I/O last week I was in I/O, and they just announced that their Chrome can render in OpenGL and do hardware rendering and everything, and even on stage it was jumpy and junky and a lot of staggering. So WebView is just not there, and I don't think it will ever be as good as native. That's just several layers along the way. There's got to be some overhead there. Okay, thank you very much.